Alright, so section 4.3, this is the conclusion of this chapter. We've talked about binomial distributions. There are two other ones, two primary other types of probability distributions that we'll learn about. One is called a geometric, and the other is named after a French person. It's called a Poisson distribution. That's how you pronounce that word. Poisson is the French word for fish, apparently. So let's talk about how to do those. So first of all, geometric distribution. As they point out here, things in life are sometimes repeated until a success occurs. Okay, and when you're talking about doing something until you get your first success, that is a geometric. Okay, the difference between a geometric and a binomial is, I'll give you an example. Okay, let's use a free throw example. A binomial would be something like this. You take 10 free throws, and what is the probability that exactly 8 are made free throws, right? That's a binomial problem. A geometric would be somebody is taking foul shots. What is the chance that they make their first shot on the 10th free throw, let's say? So let's say the 10th shot, what's the chance that they make it on the 10th or before the 10th or after the 10th, something like that. So it's all concerned with when does the first success occur, and you'll see some examples in just a sec. Okay, same conditions, that the probability of each is independent. Okay, it's the same for each trial, and then x still represents the number. Okay, and there's a formula way to do it, which is shown right here, and there's a calculator way to do it, and I will show you both ways. All right, so let's start with the formula way, and then I'll show you how to do this in the calculator also. So I think we did example similar. LeBron James makes a shot about 75% of the time. Find the chance that the first success, in other words the first make, occurs on the third or the fourth. And that word is important, or, right there. You might remember that or means plus. So we want to find the probability that he makes it on the third, or, meaning plus, the probability that he makes it on the fourth. Okay, the formula from the last page is right here. I'll put it right here. Okay, it is the chance of success times the chance of basically failure. Okay, now here's the idea. Okay, we don't know how many shots it's going to take him. So here's how we set up. Let's start with the third first. Okay, the probability of the third, we have to use this formula. So P is 0.75, and then we want the success to occur on the third. So in this case, x is 3. Why would you be raising it to the x minus 1? And here's why. By the way, if the chance of success is 75, that means Q, the chance of failure, is going to be 0.25. Okay, why is this x minus 1? Here's what I want you to imagine. If he's taking foul shots, right, if he's making it on the third, and the first will be a miss, and the second will be a miss, and only on the third will he be making it. So the reason why this is x minus 1 is because if your success is occurring on the third, that means you must have had 2 misses, and that's why we're raising it to the second. If it was asking about the 100th attempt, then this would be raised to the 99. Because if you made it on the first time on the 100th, that means you had 99 misses. Okay, so we have to put that in the calculator, and then we have to add to it the same thing right here. So the chance that I will make it I always have a 75% chance of making it, but if I made it on the fourth one, that's this one right here, if I made it first on the fourth one, I must have had 3 misses. So we have to find what those two are and add them together. Let me show you how to do it on the calculator. You could just add these by hand, but there is a way to do it on the calculator. So you go to second vars, kind of like we did for binomial. Okay, and what you want to select in this case, you have to scroll down a ways. And you are looking for this right here. You're looking for geom-PDF, geometric probability distribution function. That's E, at least on mine. So select geom-PDF, and it will ask you a p-value, which is 0.75, and it will ask you an x value. Okay, and that's the chance of getting it exactly on the third. So you'd have to plug in this first, okay, and then you have to do it again a second time, but this time you have to do it on the fourth. So you need 2 numbers, and then you just add those together. So I'm going to do this right now. So 0.75, and then I'm plugging in the 3 first. And this one turns out to be 0.046875, which is going to be the same as that number right there. And you can verify that if you're not sure, but this number right here turns out to be 0.04675, which is coming from here. And then the second one, that's this one right here. Okay, if you want a shortcut, by the way, you can hit second enter on your calculator, and we'll just pull that same thing back up, and you can replace whatever was there before. So 0.01171875. If you were to add both of these together, of course you could store those numbers too to make it a little bit easier. But when you add those together, you get a final answer of 5.86%, or 0.0585. So the chance that the first one he makes occurs on the third or the fourth is this. Now that's pretty low, but keep in mind he's a pretty decent free throw shooter, so it's likely that he's going to make it before the third or the fourth. That's why it's such a low number.